Before venturing into the world of Riemann sums, which are used to approximate areas, before venturing into like this crazy summation notation, the thing that gets programmed into your calculator, when you type this into your calculator, it uses a Riemann sum. We learn about integral properties and stuff to kind of help us understand area just in a different way. We got to remember that, Newton says, hey, if we can take an antiderivative, take the antiderivative and get the answer. And this first integral from the first lesson, you can actually take the antiderivative of. Today's lesson, we go back to the basics. Before calculators were invented, before programs were programmed, mathematicians could find areas by taking antiderivatives. Okay? So, this lesson is back to taking antiderivatives. This could be considered Unit 6, Lesson 5. Unit 6 was all about taking antiderivatives. Okay? Some of the questions you're going to have, you've seen before. Because what we're going to focus on are like that first function that I showed you. We're going to try to take the antiderivative by undoing the chain rule. Okay? Now we need to remember, and this is called U substitution. Think of this as undoing the chain rule to take antiderivatives. U undo, sure, makes sense. Put that away. What are you doing? Are you kidding me? Can you put your phones away? Take them off your desk. Off the desk. You don't need it on the desk. Take it off the desk. You can focus for the next 35 minutes. Okay. To undo the chain rule, you need to know how to take the chain rule. You need to know how to take a derivative of something like this. So take the derivative of this. Yeah, this one. Take the derivative of cosine 3x plus 2. If you need to use O and I, do it. Derivative of cosine is negative sine. Derivative of 3x plus 2 is 3. This is negative 3 sine 3x plus 2. What's important about the chain rule? What starts in the parentheses stays in the parentheses. That is going to be a common theme for today's lesson. Take the derivative of this. Log, change this to 2x squared plus 3, just so I can show you something. Take the derivative of log 2x squared plus 3. You know how to do the chain rule, you'll know how to undo the chain rule. Scott, put your phone away and jump in on this lesson. No, not on your lap. In your pocket, in your bag, put it away. No, you can. It's okay. Change it to 2x squared. Clark White.
2x squared.
Okay, we need to remember the derivative of the log function is a 1 over or a negative first power. The derivative of the inside is 4x. We could write this as 4x over 2x squared plus 3. Okay, cool. Now, today's lesson, we're going to go backwards. We're going to take this, undo the chain rule, and get this. We're going to take this, undo the chain rule, and get this. Okay? I'll show you how. You've already done this. You've already done this. You've already undone the chain rule in Unit 6. You already know what the antiderivative of cosine 3x plus 2 is. See if you can get it right without me reintroducing it to you. To review, if you don't get it right, it's okay. What did you do and what are you going to do? Pay attention to the chain. Pay attention to the parentheses. What starts in the parentheses stays in the parentheses. Remember that the antiderivative of cosine is positive sine. The antiderivative of cosine parentheses is positive sine parentheses. Undo the cosine. You get sine. What starts in parentheses stays in parentheses. Plus C, but I'm wrong. What did I forget? Look at you guys. You guys are ready for today's lesson. You know, because of the chain rule, that the derivative of the inside produces a 3. We need to undo the derivative of the inside. Okay? Now, what if I had like a 14 up here, and I asked you to take the antiderivative of this? What if I had like 7 in front of the cosine? Would that affect anything? Like, no, you would just worry about the 7 at the end, and it would kind of be incorporated with the 1/3. No, I wouldn't worry about the 14. It's just like something, and we'll worry about it after we take the antiderivative. So you might not see a chain, but it's there. There's parentheses to the first power. So I'd write that as 14 times parentheses to the negative first power. And I'd remember that the power rule doesn't work for that power. We get a log. What starts in the parentheses stays in the parentheses. The 14 is still there, but we need to undo the derivative of the inside. We need a half. And you guys are all ready for that. And then we can combine the 14 and the half. Got it? Okay. This one. Actually, just replace it. I just want you to practice something with a power. So it doesn't have to be a negative power. I'd prefer it to be a positive power. Replace it with 3x plus 4 to the positive second. So 2 times 3x plus 4 to the positive second. Take the antiderivative of that. One more practice one, and then we'll get to the trickier ones that you're going to see today. One more one that you've seen before, that you should know how to do, that we're reviewing. Get this, tell your neighbors. Go ahead, do it. Today's not a day to just look. Today's a day to do. This is not a conceptually driven lesson. This is more a procedural lesson. If we lost our notes packets, I have extras. Nope. Nope. Yep. All right. We focus on the chain. We focus on the chain. We take the antiderivative of the outside. I need a 1/3 from the 3. So this 1/3 comes from this 3. What starts on the inside stays on the inside. So the 3x plus 4 stays there. But because of the derivative of the inside is 3, I need another 1/3. This 1/3 comes from this 3. The 2 is there, it stays there. We just worry about it at the end. I should get 2/9 3x plus 4 cubed plus a c. We won't have to worry about c's today, but I'd like you to put them down. But the only different type of question I'm going to ask you is to find an area under this. I might put a number 0 and 1 here. If I put the number 0 and 1 here, this is something we didn't do in Unit 6 because we did not have the understanding of antiderivatives and areas can be found with each other. To find an area, use an antiderivative. Boom, I would just put a 0 and 1 into the antiderivative at the end. 2/9 7 cubed minus 2/9 4 cubed. Whatever that happens to be, that would be my area under that. Cool? Does that confuse anybody, the whole, like, we can take an antiderivative to find an area, just like you did on your quiz today with the f double prime question, right? All right? So, I'm not even going to show the notation. We're just going to go straight to this. You guys understand. You guys know we need that undone derivative of the inside. Okay. Now you look at these, and a lot of people think, oh, these are different because these are products, these are quotients. Mr. Messner must now teach me the product rule or the quotient rule for antiderivatives. And I'm going to tell you, no, there is no product rule. There is no quotient rule for antiderivatives. These are actually the exact same as these. Let me show you. Ready? What do we see is a chain? Okay, I see a chain. I'm going to focus on the chain. What did we do with the extra stuff in front of chains on the previous question we did? We kind of just ignored it. We just said, let's just worry about it later. Okay? Cool. What's something we understand with chains? What starts in the parentheses stays in the parentheses. Okay, that will still happen. So let's start by taking the antiderivative of the outside. Okay, take the antiderivative of the cube. Does everybody put a 4 and a 1/4? Cool. Cool. What starts on the inside stays on the inside. X cubed plus 3 stays. Cool. The x squared, it's still there. It's just like keep it over there on the side. But what is the thing that we had to do on all the previous ones? We had to undo the derivative of the inside. What is the derivative of the inside? Tell your neighbors. It's not just a number. It's a number times an amount of x's in this case. The derivative of x cubed plus 3 is 3x squared. How would we undo that 3x squared that's going to show up? Well, we multiplied by 1 over the constant before. Why don't we multiply by 1 over the derivative? Now, why did Mr. Messner say ignore the x squared? That's a product, Mr. Messner. There's got to be a special rule for it. Because when you focus on the chain, you will get rid of the product. The x squareds will go away. What we will have for the remaining antiderivatives we will see is a situation where a chain's derivative turns into a product. But this that we're going to take an antiderivative of comes from a chain. Don't believe me? Take the derivative of this for practice. When we focus on the chain, we will be able to naturally just eliminate the product. We will be taking antiderivatives of things that come from a chain's derivative. You're on the wrong page. We got lots of space. It is the same question, yes, but we just have more space. All right, don't believe me? Take the derivative. Have we taken the derivative? This is not something to just stare at today. Don't stare today. This is a we must do and learn and practice and understand. Four times the 12th is a third. So, when we take the derivative of O and the derivative of I got a 1/12 of 4. What starts in the parentheses stays in the parentheses cubed, and a 3x squared. What happens? That and that cancel. It's a 1/3 and a 3. We just get x squared times x cubed plus 3 cubed. X squared times x squared, x squared times x cubed plus 3 cubed. We are going to undo the chain rule today, taking things that start as products and turning them into the antiderivative, which is a chain. Got it? Now, below here, we're going to do two examples, but they're going to be very similar to each other. The first one, please come over here and do this one for me. An easier example. 3x times 9 minus x squared squared. You see a product, but the product comes from a chain's derivative. If you undo the chain, rule, you will get rid of the product. You will find that there is some chain whose derivative is this product. Ignore the 3x, do the one on the right first. Ignore the 3x. Just pay attention to the chain. Just ignore the 3x, pretend it's like a constant. I got an option for you. I can give you the retake, shorter, easier, but I can only max your grade out at an 80. I want to give you the actual test. Longer, more difficult. It's up to you. Think about it for a second. Come back. Just one negative, and you're good.
I'll go check my backpack right now.
Oh, layout.
Yep. Good. Got it? Some of us don't like this. Did I tell you to put your phone away? You're addicted. You're addicted. Put it away.
I already.
Gotta keep my followers happy.
I do.
Okay. Focus on the chain. You got what? Is that true?
Yeah. I'm at like 32.
What's a K? A what?
32,000.
Oh, cool. Keep that grease supply fresh, okay? All right, ready? Focus on the chain. What starts in the parentheses stays in the parentheses. Ignore the product. When we undo the chain, we'll get rid of the product. What starts in the parentheses stays. Understanding the chain rule, we know we'll have to undo the derivative of the inside, so I have a 1 over negative 2x. Now, if this was my answer, it would be wrong, because this is a product of x's times x's. But that 3x is there, and that 3x cancels with that 2x, giving me a negative 1/2 9 minus x squared cubed plus c. A chain, not a product. A chain whose derivative is a product.
Wait, why did you do 1 over negative 2x and not just negative 2x?
Why did we do 1 over 3 here and not 3? Why did we need the 1/3 there? Why didn't we put a 3 there?
Well, I thought you were supposed to put a 3 there.
No, a derivative will have a 3.
Oh.
The derivative has the 3. I want to undo the derivative, which is why I need a 1.
I get confused like switching.
I know. All right. Do this one on the left side. Go.
Oh my gosh.
Why? Because your calculator doesn't know derivative rules. What does your calculator know? A slope formula and a limit. The calculator plugs in to the slope formula 1.1100th away and 1.100th left, and uses y2 minus y1 over x2 minus x1, which is why it gets an approximation. Your calculator is getting approximations with integrals, just is very, very good and accurate. Do the one on the left, go. Okay. Focus on the chain. When you undo the chain, you undo the product. When you undo the chain, you'll undo the product. Watch what happens. The x's go away. The 2's go away. The 3's go away. You just have negative 9 minus x squared to the 3f. Okay? This one. Now, we just did 2 in a row that involve powers. So everybody gets confused because they're like, oh, the antiderivative of sine parentheses is negative cos parentheses squared times that. No. The antiderivative of sine is just negative cosine. The antiderivative of sine parentheses is just negative cosine parentheses. There's no power rule that you need to worry about because there's really no power, okay? So, try this one out now.
I've been doing them.
I had it all. You're so stupid. What?
But it's okay, you're getting it right. All right. Focus on the chain. The chain is the sign parentheses, negative cosine parentheses. What starts in the parentheses stays in the parentheses. You need to undo the derivative of the inside. So I need a 1 over 4x cubed. The derivative of the inside is a 4x cubed. We have to undo the derivative. X cubed is there. The x cubes will cancel. We eliminate the product. This chain's derivative turns into that product. Now, please do this one, but when you're done, plug in 0 and 2 so you can find the area under this function from 0 to 2. Focus on the chain. Now, why are we focusing on the chain? What we should notice is that the derivative of the inside cancels with the stuff on the outside. Why do we ignore this stuff? Because it's going to eliminate itself when we undo the derivative. Scott, if you were looking at your phone, I'm already mad at you. I've already hit you once today. I don't like.
That's right.
Yeah. So we'll hang out. I'll tell you what's happening. If you hang out with the student section, no, I'm out. I don't hang out in the student section. I don't know. All right. I'm losing you guys. I get 2/15. X cubed plus 1 to the 5th. Shush. From 0 to 2. Now, it's going to be something that I don't want to simplify. And that's okay. We're okay with that. 2/15, 9 to the 5th, minus 2/15, 1 to the 5th, or 2/15. That is my area. Mr. Newton says, don't worry about programming. Just take an antiderivative. You get the area. Questions? Okay. Now, I'm just going to show you other variations of the same thing, not new, starting with this one. Don't forget, the antiderivative of e to the x is just e to the x. The antiderivative of e to the parentheses is e to the parentheses plus c. You don't add 1 to the parentheses. You don't multiply by half. That's just different. This is not a power, x to a power. This is e to the x. So it's different rule. The antiderivative of itself is itself. So focus on the chain. Undo the chain's derivative. If this is set up correctly, you will be able to undo the product, so you just have a chain. You then realize you're trying to find an area from 0 to 1. You're using an antiderivative to find the area. You get 1/3 e cubed minus 1/3 e squared. Okay? We do this one on your homework. We're going to do this next class after spring break. We're going to do this after spring break. We'll do it after spring break, and it'll be on the test. We have 2 review days, CJ. So if you don't remember it after spring break, we get to review it. We have 1 review day Friday. We have a review day Tuesday after spring break. Okay. Remember, with any power other than a negative first power, we would use the power rule. We skipped a couple of things. We'll come back to it after the break. For this guy, we have a negative first power. Don't forget, power rule works for every power except for this guy. Break out Mr. Log. Now, since the derivative of 3x plus 2 is just 3, we know we just need a 1/3. Right? Look at the one on the bottom right of this page. It becomes a little trickier to identify when it's not just 1/3x plus 2. When you have x's divided by x's. Dang it, stop. But here's what I want you to try to recognize, is that the numerator is a version of the derivative of the denominator. Or, here's what I want you to attempt. Rewrite that so you do see parentheses and you do see a change. Now, what you haven't really paid attention to is the fact that this power is always 1 more than this power. That's how we are undoing a change. That's why this comes from a change derivative, because it's part of like the derivative of the inside is that. That's why it's going to cancel. I would never give you a question where this is like a 4th power and this is the 1st power, because when we undid things, we would not undo the product. We would just have another version of a product. So what you do after either recognizing that or rewriting that is you use the log because it's the antiderivative of the negative first power. What starts in the parentheses stays in the parentheses. You undo the derivative of the inside, which will remove the product. And you have your antiderivative. Okay? Now, go back a page. 2 pages.
Oh no,
Yep.
Yeah.
Well, there's only one lesson. There's no lesson on Friday. It's just a quiz. Yeah, we're done with the unit after this lesson. Okay. All right, we are becoming pretty adept at this, so go ahead and take the antiderivative of that. X squared plus 3 squared. There will be something wrong with this one, but I'd like you to do it using kind of the procedure we've been doing. Just do it. Get the answer. Take the antiderivative of this. Be 1 over 2x. Undo the derivative of the inside. Undo things when we're taking antiderivatives. Yep, that's what I want you to get. I want you to get the following: a 1 over 2x, a 1 over 3, to get 1 over 6x, x squared plus 3 cubed. Let's see. What is different about the answer that I just put down compared to all of the other answers that we've gotten for all of these antiderivatives? It's a product. Hold on, guys. I thought this process removed the product and we just started with the chain. This is x's times x's. If you took the derivative of this, you'd have to use the product rule. I wanted to undo the product rule. This is wrong. Just because you see parentheses doesn't mean the right approach is to undo a chain. If you ever undo a chain and you create a product, you did something wrong. If there was an x outside of this, you would be able to do this procedure. If there was an x that could cancel with this x, you would be able to get the right answer. But what I need to remind you of is sometimes simplification is the way to go. Sometimes, and you have a test question just like this after spring break, the best thing to do is to just rewrite it by squaring x squared plus 3, x squared plus 3 times x squared plus 3, x to the 4th plus 6x squared plus 9, and then take the antiderivative of all of those things. All of these examples here and on the bottom of the first page of your homework, you will have to simplify. Okay, now go to the last page. We're skipping all this change of bases. I'm going to teach you later. And we go to that. Okay. The key to this class, the key to the second semester. What do you have? What are you trying to find? What do you have? I have the graph of f. What am I trying to find? An integral of f prime. What do I have to do to find the integral of f prime if they're giving me the graph of f? Tell your neighbors, what do you think? The answers are either use the area or use some of the points. Ready? We should try to take the antiderivative. We should try to see what this is equivalent to in terms of f, because this is the graph of f. Now, what's the antiderivative of f prime of 2x? Well, start with the antiderivative of f prime parentheses. What's the antiderivative of f prime parentheses? F. F prime turns into f. Okay, so I take the antiderivative of the outside. What starts in the parentheses stays in the parentheses, right? But what do I have to do? Undo the derivative of the inside. Plugging in 1, plugging in 3, we get 1/2 f of 6 minus 1/2 f of 1. I have the values of f of 6 and f of 1 that I can find in my chart. I get a numerical answer. Try this one. Actually, please. Yeah. All right, so that covers everything I need to cover. We will learn about changing bases after spring break. We covered everything I needed to cover.